Okay, today is Thursday the 30th. This is the iPhone class. Before we start, I put this up here. If you're interested in this, let me know. Okay, it says, hello, Scott. I love that because every email I get lately has been sent to Scott, not to Jeff, but that's fine. My name is Dan Sparandio. I'm the IT director at SSI Technologies in Janesville. Danny Wright gave me your thing about students who might be looking for IT internships. Initially, this would be 12 to 15 hours with an emphasis on hardware, but they're also looking for people who have programming experience. So if you're interested in that, I know that they have already taken people there as um, interns and then offered them full-time positions. So if you're interested in that, just tell me and I'll forward the email to you. Okay? If you're not, it's not a problem. All right. A couple more things I wanted to mention. Here's one of them. All right. Talking about apps today, and I got this. 13 job search apps that will help you get hired. It's amazing. You know, it's Apple for a long time. That's what you heard was there's an app for that. All right. So, you know, just some more stuff to think about. There was a couple other things that were in here too. Of course, there it is. And I have not looked at these, so I was curious to what I saw this one. 10 programming languages that are in demand by employers, because I want to see how many of them we teach here, because I honestly did not look at this beforehand. So let's look. You're right. Programming skills. You are correct. I am incorrect. What is? Reading? Yeah, comprehending is number 2. Number 1, SQL. We teach that. Number 2, Java. We teach that. Number 3, HTML. We teach that. Number 4, well, I want to return to the scripts. JavaScript. We teach that. Number 5, C++. We don't teach that. Number 6, C#. We teach that. Number 7, XML. At least indirectly we teach that. Number 8, C. We teach that. Number 9, Perl. No, we don't. Number 10, Python. No, we don't. Honorary mention. PHP we do. Objective-C we do. Ajax we do. ASP.NET we do. Ruby we do not. So if I counted right, I think that's 11 out of 15 we're covering. That sounds pretty good. All right. Again, you may or may not agree with that, but whatever. All right. Chicago. I guess that's the nearest one. All right. That should be good enough. Okay. While looking online at all sorts of different things, all right, as I mentioned in the other period, or the other class rather, I started reading a bunch of these kinds of articles. And there are just a ton of these things out there. You know, how to make an iPhone app. The funny thing is that they don't even discuss code in here. They talk about going out and getting Xcode, setting everything up, learning. All right, so going out to the Apple iOS Development Center, which really is a wealth of information. You may or may not have heard about this, but usually I think it's every June, Apple has what they call their WWDC. It's their Worldwide Developer Conference. Okay, one of my counterparts, Eric Knapp from Madison, he has gone to this for the last 3 or 4 years. And you might say, well, it is pretty good because typically they only invite about 5,000 people, and they have about 20 times that many requests. All right. They introduce new hardware, and there's a lot of really good stuff. The reason I'm telling you that is if you ever have an interest, if you go out and Google, I didn't want to even bring that up. So if you go out and Google Apple WWDC, you can see as an example here from 2013, what they do is they take virtually everything that's in there and record it. Almost all of the sessions are recorded, and they're put up there. I believe some of them you just have to be a registered Apple developer. I think some of the rest of them are available to anyone. And they've got some, I actually watched a couple of these. This was like maybe from 2012 or 2013, I don't remember, but it was at least a couple years ago. All right, probably 2012 then. But there's some really good stuff, and it's out there for free if you ever have an interest. Okay. Then they say experiment. Okay. Set up your app. Okay. This is what I'm having the problem with. This is what I wanted to get to today. I want to make sure that hopefully at least by the end of the day that everybody is in here and that we've all got profiles set up, and I'd like you to try to do something, even if it's taking one of the programs that's in the book, but try to do something GUI, because I cannot on my machine. I can do it, but I get an error message telling me that it doesn't have my provisioning profile. I set it up and I followed the steps that they gave me. They meaning Apple gave me for the developer iOS University program. They never asked me for the number of my device. I was never asked for that. I think that's the problem. So I think they've got my account associated, but they don't have my machine associated. Okay? And that's, among other things, I think that's some of the problems that I have. All right. So they talk about Objective-C and about some of the stuff you need to do and about how you should test, learn how to debug, all right, and do some other stuff, okay? But like I said, there are literally thousands, if not millions, of articles out there like this, and some of these are really, really good, all right? I've started to collect a small list of them, and I'm just going to make them available, just going to throw them out there, all right? As read through them, and the ones that I think are worthwhile, I'll put out there. I've actually got a folder that I've created up on the machine upstairs, okay? So you'll see that. All right, I'm jumping back into this book. I want to go over a few of these chapters today and then jump back to the other book because I mentioned before we'd go over chapter 4 and I never did. So I want to do that too. So I'm up to chapter 18 if I've got my bearings right here, and I think at least they're right. Your first class. And I like to go over about chapter 18, which starts on 133, to about through chapter 22. So that's about 30 pages. So that's 18, 19, 20, about 5 chapters, about 30 pages. Hopefully you've noticed with this book, good, bad, or indifferent, in many ways, one of the advantages of it is its brevity. The chapters are by and large very short. Many chapters in here are 3 or 4 pages. A couple are just 2 pages. All right? That, and as always, that's both a blessing and a curse, because sometimes they start to go into things and they might give you a code snippet where if they gave you an entire program, that would probably serve you better. All right? But again, what I'd like to do today is to go over those 4 or 5 chapters, then go over chapter 4 from the other book. If we get that done by break, fine. If we only get 18 through 22 done by break, that's also fine. I don't really care. And then next week, I do want us to go in, and if everybody is here, I want to hook my machine up, and I want us to build a bunch of stuff as a class. Build a couple of them on Monday, or Tuesday rather, I'm sorry, on Tuesday, and then on Thursday go back to that tip calculator and try to build that tip calculator and build that as an iPhone app. So you can start to see the difference between them. I've got a whole bunch of projects that I've started, and what I have to do is, rather than starting a project, getting it half done, and starting another one, I've got to do a better job of finishing the ones that I'm starting. All right? Because I mentioned that Magic 8 Ball, and I'd written that before and gotten it to work on the Android, and I was playing around with it on the Mac and got it somewhat working, and then same kind of thing, that I started making changes and it locked up. I don't know what happened. All right, and I never went back to it, but hopefully we'll be able to do that. So, your first class, what they do is they use something that we've used before in other classes. We've used, or they use the old BMI type of class in here. That's what they use for the example, body mass index type of thing. Hopefully by now, everybody does realize this thing right here, all right, that's that class prefix. So he uses BNR for Big Nerd Ranch. I recommend using your own initials, but basically all the classes that you create after that, they will have then your initials on it. You don't have to do that. Apple recommends that you do that. Also, Apple recommends that if you do that, at a minimum, the extension that you put in is 3 characters. Don't put in 2, because 2 is what they use. So if you go through their documentation, that's why they say it because most people have 3 initials. I know there are some that don't have a middle name, but it doesn't matter. All right? And so they recommend that you use your 3 initials in there. Okay? That's why in many of the examples, if you've gone through any of the code that I took out of the book, and the ones at the end of the chapter that I did, I just used BNR because that's what he had used. All right? So, it says they're going to write a person class that'll be similar to struct person you wrote in chapter 11. Okay? The class will be defined like all of them are in two different ways. The .h for the header file, the .m for the implementation file. Now, and I'm showing you this, and some of you have looked at this. You might have even started playing with it, but just so you know, okay? Literally right here between iOS and OS X, these are two different frameworks. Does that make sense to people? Technically, if you go to OS X, all right, if you do go to this one, okay, and you just click on here, I believe it's under OS X at least, one of the ones that's over there, not under Cocoa, but if you just click on here, one of the ones that you'll see up here will say command line. And that's what he uses in here almost exclusively in this book. The reason I'm telling you that is there isn't a command line under this one. Okay? But what I want you to understand is where it says iOS, notice that right underneath it, it says Cocoa Touch. Cocoa Touch is the framework. It's the set of predefined, kind of the API, whatever you want to call it, of classes that have been set up for iOS devices. Okay? The OS X is technically stuff that's been set up to run on a Mac. You understand the distinction? All right, so we're talking iPhone, iPad, iPod. All right, especially some of the higher tech iPods. And we're talking here just Macs. Okay? And hopefully you've noticed, if you haven't got a chance to do this, you will hopefully next week then, that, go ahead and highlight the different things under here and take a look at what the descriptions are. All right? I'm not saying they're great descriptions, but they're not bad either. What you will notice is I had you download Xcode, and I don't know, what was it, Xcode 5.0 or 5.0 point something? I don't know. What? 5.0.2? Okay. And the one I have on my machine just says 5.0, but my guess is it looks virtually identical to what you have. But the reason I'm telling you that is that Apple made a choice that after about 4.5, they changed a lot of stuff where you used to have to, when you would create a new class and that you have to check this box and check this box. People were doing pretty much the same thing all the time. So what they did was they made all of them defaults. So there's very little you have to do when you start up. All right, things like ARC, automatic reference accounting. It's just done for you automatically. You used to always have to say you wanted that. All right, so we're going to look at some of that stuff as we go on in here. Okay, we looked at this. I believe we started to look at this before. And as I mentioned to you, I think it was last week, that's one thing is when we miss enough class, I get my days and my weeks and my whatevers mixed up. But if you look on here, as it says, these are two instance variables. The reason I'm telling you that is this is right here. All right, it says find bnrperson.h. Open bnrperson.h and declare two instance variables. If you declare instance variables like that, they must be within the curly braces. If you declare method headers, they can't be within those curly braces. Everybody hear that? Now, what you'll see as we go on and we get into a chapter a little further up, believe it or not, you don't even have to declare these variables. There's another way of doing it where you don't even have to declare your variables like that. So you'll see that in a little bit. And as I mentioned to you previously, it's not mandatory that when you declare a variable like this, you put an underscore. But most books, not all, but most books will tell you that if you do create instance variables, you should create them and have an underscore at the beginning, and then your getter method should be the same name as your variable without the underscore. Did everybody hear that? All right. Okay. So what we have here is the beginning of our interface and just our two instance variables. Then we come up to the next page here, and now we have the rest of it. Again, hopefully all of this stuff now, at least what's going on in the stuff here in blue, makes sense to you. So what do we have? We have 5 different method headers. All right, we're saying that we have 5 methods in this class. All 5 methods are instance methods. So we need an instance of a person class in order to be able to call these. You can't just you can't say BNR person dot. It wouldn't work. Or BNR person in the brackets. It wouldn't work. You have to create a person object. All right. Again, 2 of them return floats, 2 of them return nothing, 1 of them returns an int. All right. You can tell by looking at these because we've got a variable called underscore height in meters and a variable called underscore weight in kilos. So hopefully you can tell by looking at those. Those are your two getters right there. They don't require anything, so you don't even need an empty set of parens right there. In fact, the recommendation is you don't put any empty parens in there. But you have to put the return type first, in parens. So weight in kilos is returning an int. Height in meters is returning a float. All right. The two set methods, here and here, neither of them return anything. They both, one requires a float. All right, and it's the same that we saw here for height. One requires an int, the same thing we saw here for weight. All right, hopefully by looking at that, that just makes sense. Okay, because it's very similar to the stuff we've done previously. As you look through here, so that's everything. That's the entire .h file. So if we go over to the .m file, it's here. And you'll notice when you look at it, it looks very similar in nature. The syntax is different, but it looks very similar in nature to the stuff that we did in regular Java. What do I mean? Well, for instance, there's a getter, return followed by the name. That height meters guy has the underscore because that's the actual instance variable name. All right, and again, we're saying that height in meters must return a float, and it must be called by an instance of a person class. Set height, all right, and again, is this well written? I'm not saying it is or it isn't, but it's expecting a float. All right, it's expecting a float that we'll refer to as h, and we're going to take that value and we're going to set it to height in meters. There's literally, there's no validation that's being done here. In other words, I can put a negative number in there, and it'll work. The system, or I can put a negative weight in there, and it'll work. Okay, I can put in a height that's astronomical, and it'll work. Same thing with a weight. So what I'm saying is we could have decided to put some checks in here, but they didn't. All right, maybe it's because he's just starting. I don't know. All right, but the only one that's in here that we're actually doing any quote work unquote in is right here. Okay, and I think the reason he used kilometers and meters is you don't have to worry about that 703 because when you do that the formula is a little bit easier. I'm not sure. Okay, I mean if you looked at the guy, his picture's on the back here. Okay, he looks to me like he's an American, and maybe that's a bad thing to say one way or the other, but I don't know, he's just a guy with a cowboy hat on, you know. He could be from anywhere though, who knows. All right, so that's the whole program basically. Then they say go and open up main.m. When you do open up main, well, you want to somewhere in main you want to be able to use the stuff that's from that header file. In other words, you want to be able to call those methods, all right, that are in the bnrperson.m file, correct? Since you want to be able to call those, you've got to bring them in by using the import statement, okay? All right. This, again, this line right here, that curly with the auto release pool that ends there, that's one of the things I mentioned that was added in about Xcode 4.5. Previously, you had to do reference counting yourself. That's automatically taking care of it for you as you're adding and removing references to objects, etc. Okay? So what are we doing here? Hopefully by now, this isn't anything new. Because we looked at this, we looked at something like this, and we may have even looked at this one before. I don't know, but I want to make sure you get it. So we're saying, remember, we want a reference to an object. What kind of an object? A BNR person object. So it's star Mikey, and you know this already. What this is going to say is it's allocate a person and then run the init method. All right? And once we've done that, then go in and set Mikey's weight and set Mikey's height. All right? And then log the instance variables using the getter. So now we're taking them and throwing them into local variables here and here. All right? Then we're doing the NSLog right here. Okay, here's a question for you. Do you think that rather than creating local variables like that, in your NSLog statement, what I'm saying to you is rather than having these 3 lines of code right here, do you think that we could have done the equivalent of like chaining and written them where in here we would have said @Mikey is all this stuff here, but in here instead of having these lines, could we have done this and this? The answer is yes. Why couldn't we have? All right. Now, maybe this person is thinking ahead and saying it's possible that someplace we're going to add more to this program and we want to be able to use the height and the weight individually. I don't know. I mean, not being the person, I can't answer the question, but I'm just saying these are the kind of things that as a developer, there's always different ways. And I don't know about you, Bob, but I know that I've been at plenty of code reviews where somebody'd say to me, you know, you did it like this and it's fine, but you know, you could have done it like this. Yeah, I know that. Why didn't you? Because I didn't. You know, sometimes that's the only answer that you can give to somebody. Why didn't you do something? Because I didn't. All right. I mean, if it's in the jQuery class, you know, we're going back and we're reviewing JavaScript in there, and we were talking about a bunch of stuff, and I showed them like 3 ways of doing something in class yesterday, and I said, now that said, if I were you, and I think I've said this to you, I'd say pick out the one that's easiest to you and use that one all the time. You're not impressing people by using 3 different things. I don't think you are. I'd rather you know, use one thing and use it well. You know, and they're like, well, then why are you even telling it? Because it's in the book. And this way, you can make an educated choice as to which one you prefer. You know, people say, well, which one do you use? All right. Why should, you know, I'll tell you if you really want to know, but I wouldn't definitely, I wouldn't use something, for instance, because Bob said, well, you should use that. Or because Keegan said you should use that. I'd try it maybe, but I wouldn't necessarily use something because somebody else did. All right. So we've done all this stuff, and then we log it. Okay? And then as it says, log some values. So what are we doing? So we're figuring out the BMI right there, and then we're going to print it out. The key things here, because we've talked about this before, all right, again, if we did call this directly right here, we'd have to look and make sure what we still wanted, the 0.2F and the 0.D, since they are returning those kind of values, we would. All right, but remember that any time, 2 things. First of all, NS logs start with the @ sign. Again, that's just get used to it. And second of all, if you're printing out an object rather than a variable, then it's going to be % followed by another @ sign. Okay, and I think we talked about that before. All right. And I guess what the author's trying to do in here is he's trying to compare and contrast writing this as a program using structures versus writing this as a program that you're writing in Objective-C when you're using classes. Okay. Some of these conventions, we've talked about this stuff already. Again, getter methods are typically given the same name as the instance variable, except if you do have an underscore like we have here, you don't use it. That's all. All right. And we've talked about this before. Setter method declarations. Yeah. With variables and with methods, camel casing, and the first character is lowercase. With classes, all right, the first character is uppercase, and then you use camel casing. All right, this BNR, that's just the, remember, that's the class prefix. But this, if this had been BNR person hello, then the P in person and the H in hello would be would both be capitalized, type of an idea. All right. Hopefully another thing that you've started, at least started to notice is it says, notice how your project now has an executable code file and 2 code files, the main.m and person.m. All right, the main.m is just that. That's main. You're typically, as we get into this, you're not going to do anything with main. We're going to talk about main next week. All right, you're typically not going to do anything with main.m. Typically, you're going to create classes, and in those .m files, that's where you're going to do all your work. All right. So I do have this out here, so if you want this, I wrote this one based on what they had here, and I did it. There's different ways that you could do it, but I tried to basically pattern it after the same one that's in the book. All right? The one that we just went over. All right, okay. Okay, now, notice what he's doing here. If you look up everybody, just to take a second and look on the screen. What he's telling you is you can put those 2 lines of code that you see there, here and here. These 2 lines, if you put them in there, they replace these 1, 2, 3, 4, 5, 6 lines. When you make a property designation like that, what the system does for you, right there, and we'll get to it, what all of it means in just a second. But what that does is it creates the variables by those names, it creates a getter for you, and it creates a setter for you automatically. So again, by putting in those 2 lines of code, 2 lines have replaced 6 lines. Forgetting about the comment that's in there. So let's break this down. It's a property designation, all right? Since it's a property designation and not technically a variable, it doesn't go in curly braces like that, okay? And the next thing you see here is non-atomic. And what atomic and non-atomic mean, and you know, some of you might have a better understanding of this than me, but if you're working with a threaded program where you've got a program that something can be happening and something else might be happening in the background, and then when that finishes, something else happens in the background, etc., etc. If you want to be able to have whatever you're working with persist among these different threads, you make it atomic. All right, virtually for everything we'll do, in at least in this book and in most of the class, it'll be non-atomic. Now, it's unfortunate that the people who created Objective-C, for whatever reason, decided that the default would be atomic. So if you use a property designation like this and you want it to be non-atomic, in other words, you don't want to have to worry about writing program threads, etc., you have to put that in there. And technically, non-atomic properties like this will help the program run faster than atomic ones will. Because, again, it has to do with all the work that goes on behind the scenes and some reconciliation, etc., that has to take place. Okay? All right. And it's saying that we're creating a new variable called, oops, I clicked it again. It was my fault. It says that we're creating a new variable that's called height in meters. Notice you don't use the underscore when you use properties. Don't. And it's of type float. And you don't have to write those. They're just available to you. You can then just start calling them if you need to. All right. So, again, you can read this, but I just, rather than me reading it to you, again, all those go away. This is your .m. That was your .h file. This is your .m. So now the only one you have to worry about is the actual calculation of the BMI. So it really cuts down on the code. Now think about it if you've got a complex class that has a dozen variables in it. Now that's 24 methods that you've just cut out. That's a pretty big savings. Even though, as you can see, these methods are short. It's just less that you have to worry about. And again, I mentioned this to the class in the jQuery class yesterday, that as time is going on, software is getting smarter. Now, I don't know if that's a sign that developers are getting dumber, and it's not a joke, but more and more is being done for you. And you might say, yeah, that's a good thing. Yes and no. Yes, it's a good thing if it's done for you and it's been tested, etc., etc. But sometimes, this isn't an example of that, but sometimes if something's being done for you, it's now being shoved down your throat, and that's the only way you can do it. And I would make the case that I would at least like to have the ability to be able to go in and change stuff and do it my way. You can still write your own, you don't have to use these property things. You don't have to use those. Okay, you don't have to. But if you use them, and you're going to write very simple getters and setters, they're written for you. If you decide that instead, especially in your setters, you're going to do a bunch of validation in there, then you'd still want to do them like that. All right? As it says, if you do that and you build your program, it'll work exactly as it did before. And there should be an example of each one of those in there on the file that I gave you, okay? Or on that folder for that chapter. It says, what about the instance variables? The compiler created instance variables, underscore height in meters and underscore weight in kilos. All right? However, you do not see them in your code because they're no longer any explicit accessor implementation. So from here on out, the rest of the book, the author says, geez, unless I have to, I'm going to use properties all the time. Notice, Apple recommends using them when possible. All right? And it goes back to what I just mentioned to you, though. Apple writes, I think, and they're no different than Microsoft. Microsoft, they put out a book years ago, how to code the Microsoft way, where they showed you how to set up menus and everything else. They do that for a reason. They want your stuff to look in a standard way. Their thing is, well, if it does in that standard way, it's a standard look and feel, etc. But in a way, when you think about it, isn't it an advertisement for them? if you make your apps look like Microsoft apps? I think it is. All right. A property declaration can have one or more property attributes. We started talking about these. Okay. So as it says, technically talking about atomic and non-atomic, all right, is beyond the scope of the book. They do mention it talks about multi-threading, etc. The other thing is when you create these, see that? That does pretty much what you think it would do. In other words, when you do that, it'll create the variable and it'll make a getter, but no, there's no setter. Does that make sense? All right. It's funny too because this is the default right here. You don't have to write these. And notice it says properties are either read-only or read-write. So I started thinking, because I know that in a lot of databases, there also are write-only things. So I found a book that says you can also put write-only, but I haven't found it in any other book. So, you know, where something you'd be able, you wouldn't have a getter, but you'd have a setter. You might say, well, I'd never want one of those. But just out of my own curiosity, all right, so I started looking. So to my knowledge, all right, it's got to be one of these or the other, just read-only or read-write. Even though, as I said, one other book said you could do it that way too. So, all right. Now, here's where it gets a little confusing. They talk about dot notation. Okay? Remember structures? Name of your structure, dot something. Remember that? Remember how this has changed now by using these brackets? Well, let's look at this section. Objective-C programmers use accessors a lot. When properties were introduced, Apple also introduced a shorthand dot notation for calling accessors. Many Objective-C programmers prefer dot notations because it's easier to type. In main, it says do this. And again, you may like this, you may not. One of the things I like about the book is he does stuff like this. I wish more authors would do this. Rather than just giving you another program, show the old program and cross out what you're changing so you can really see it the way it used to look and the way it looks now. I like that. All right, and some of your heads are shaking yes, and some of you might disagree. And either way, it's fine. All right. But notice when you look at this, at least in my opinion, it looks a lot more C-like. That's why the author can say all he wants. That many Objective-C programmers prefer this because it's easier to type. I'd say no. I think many Objective-C programmers prefer it because many of them were C programmers, and they're used to doing it that way. Okay. Oftentimes, when you do something and you do it like this, you can instead do it like this. Now, the good news is most of the time, if you try it and you're able to do that, if you type in Mikey Dot, there's IntelliSense that clicks in Xcode, like there's IntelliSense that clicks in Visual Studio. All right, and it'll either give you something, or if it doesn't, if I put this in and it's not right, I'm going to get squiggly lines under it right away. If this, you know, as always, if the software doesn't understand what you're trying to do, it's not going to let you do it. Okay, but I think this is more C-like, where the other one is more Objective-C-like. Okay, now. If you're writing it, you know, again, this is the kind of thing. This isn't what you asked before, Stephen, but I could care less which one you use. If you find this one that's up here on the screen now, if you say, "But that's easier, I can really identify it with C then, etc.," then do that. If you say, "No, I think that I'm looking at a lot of code out there and nobody ever uses it," then do it the other way, or mix them. I don't really care. All right, do it whatever way is more comfortable for you. Okay. So the other thing is, notice as it says, these two lines do the same thing, but what's the difference? There's no equal sign in the second one. All right. And so do these two, type of thing. Okay. All right, let's talk a little bit then about inheritance. I think we'll get through 20, 21, and 22, and then we'll take a break wherever we are. Okay. Now, says when you created a person class, you declared it to be a subclass of NS object. Remember that everything that you create must have a parent in this language. All right, unlike Java, where I showed it to you, and then if you remember, I wrote on there extends object because I said everything does, but you never put that in there. Here you have to say it when you set it up. And if you're not sure what it extends, you just say NS object. But if we had a person, and then we said we had an employee, well, an employee is a person. All right, and again, we've looked at inheritance hierarchies before, but this should make sense really to all of you in that what this says is that an employee can do anything a person can do, and a person can do anything an NS object can do. But it doesn't necessarily go the other way. Just because somebody's a person doesn't necessarily mean that they're an employee. But if they are an employee, all right, they're a person. Now, you could raise your hand and say all sorts of stuff. I watched a thing on the news the other night where they were giving this this dog who was being retired from the army. He had been out in Iraq. He was a bomb sniffer, and he was coming home. Well, he was an employee technically, and he's not a person. But we're not. Remember, we're modeling here, so this is the way that it would usually be. All right. All right. So they tell you to come in here. It says this was a time thing that we did in a much earlier chapter, and it says open up the time project and create a new file, an Objective-C class. Name the class employee and leave its subclass to NS object for right now. All right. Leave its superclass rather to NS object for right now. Okay. All right. Then it says open this up and change it, so you can manually go in and change it. All right. If you want to do that. But this is as though we went in and when we set it up, we put that in instead. Okay. Now it is a direct descendant of being our person. And notice, in order to be able to use that stuff, notice in the .h file, notice how we have to import the parent's .h file. All right. And if we were going up the hierarchy, then that parent would be importing their parent's .h file, etc. And since we're using import instead of include, we don't have to worry that it's going to be in there. All right, and won't be duplicated. All right, so the main function here, it says we'll need to access an employee's ID and their hire date. Each employee, and this is a little convoluted example. Everybody hear that? And the reason I'm telling you that is it's because if I was associating three things with an employee, an ID, sure. A hire date, sure. An office alarm code, that probably wouldn't be the third thing that came to mind. All right, it would probably, but again, I think he's just doing it for effect and what he's trying to show here. So again, that's the three things each person has. So we're coming in here in our .h file, and we're setting up three properties. We just looked at properties, so hopefully now we know what they are. And you'll notice that when we looked at the two properties previously, we had a float, which was height, I think, and an int, which was weight, or vice versa. Now we've got an int for the ID and int for the alarm code, but now we have an object. And it's going to work the same way as far as creating the getter and the setter for us because we're using properties. All right. We're also going to have in here what? We're going to have a class method, an instance method that's going to return a double, and it's going to be years of employment. You can probably think about it, and it probably will make sense to you because there are methods that you can use with a time class where you could take today and subtract from it their start date, and whatever was left, all right, would give you the number of days they were employed. And if you took that number and divided it by 365 or 365.25 or whatever, all right, you can find out exactly how many years they've been there. Okay, so I mean, what I'm saying is there shouldn't be anything in here that's really surprising. All right, you'll be able to use that information from there to figure that out. That and the current date. Okay, so as it says, the hire date property is the first property you've declared that points to another object. So that's what they're kind of getting to in this chapter. All right, when a property points to an object, there are memory management implications you will learn about in later chapters. Again, this is one of the reasons that they decided to implement this automatic reference counting, because it works the same way that it used to. And I said this the other day, but I'm saying it again, that every time somebody creates a reference to an object, then what happens is what's called a retain count is incremented by 1. Every time you free up an instance of that object, there's a release count that's decremented by 1. All right? If those counts are both 0, that means that there's no references to the object anymore. Then what happens is the object will be removed automatically via what Objective-C uses for garbage collection. That's how it does it. All right? So, it says the compiler also synthesizes, basically creates them for you, these two things. All right, so this line right here, that line that you see in blue up at the top of the screen, that creates these two things for you. All right. So he comes through here and writes this. So implement the years of employment method. Well, he's even more anal about it than I am, because they figured out exactly how many seconds there are in a year. Okay? And you do get, I tried this. I remember putting it in here and running it, and it is amazing how close it is. All right? It also is kind of sad to realize you've been in one place like this for this long. Okay? All right. See, Bob, you laugh, but you're the only one out of everybody in here who can really identify with that. And the shine has not yet worn off the apple, because when Doug comes in, he's got this swagger that he hasn't had for a long time. All right. Okay. So it says to try out the employee class, go in there and make two changes. First of all, we have to import the employee.h file. All right. Now we don't need the person anymore, because that one imports that file. You could leave it in there, it wouldn't hurt anything. Okay? And create an instance of an employee instead of a person. All right, so now notice Mikey's an employee. You can still use all the stuff you used before. That doesn't change, because again, as we mentioned, everything, all right, everything that a person can do, an employee can do. It says the program works fine, and nothing in the output has changed. An employee is a person, kind of what I just said, okay? All right. Also note, as I mentioned, you don't need to import that file because it's already been imported. All right, it says now make the following change to main.m to make fuller use of the BNR employee class. Give Mikey an employee ID and a hire date, and set the hire date to the current date. Okay, so what are we doing? Well, we're allocating for Mikey object. There we're setting his weight, there we're setting his height. Sorry. There we're setting his height, there we're doing his ID, and here's his hire date. You do a lot of stuff like this. Part of learning this language, and that's why it's nice to have something like Xcode available, where you can do your hold on your command key and click different areas and stuff. All right, and having some pretty nice built-in help, is there are just a boatload of different methods that are available to you. And unfortunately or unfortunately, literally, the name of this method is date with natural language string, colon. All right? So hire date is equal to this. So evidently when he wrote this book, that was the date, or else that was the date he used. All right? So what's different? Well, those two lines are different. He has an ID and he has a hire date now, okay? Now when we log, the big thing is, notice what we're doing in here. All right, the ID, we've got %u, unsigned integer, okay, and we've got, as I mentioned before, %@, because we're working with an object. Okay. Now we've got double years of employment, which we already figured out. Thought we figured it out someplace. I don't know. And, oh, that's in the other. It's not in main. It's in the BNR employee.m file. And now we can print that out. All right. But the idea is, what we said was we built the person, and then we made an employee. And you've heard me give you examples like this many times in the past. It's like I make a generic bank account class, because all bank accounts have things in common. The person who holds the account, etc., and a bunch of other information. Then I get more specific. So they're talking, as we've talked about in other classes, of creating an inheritance type of hierarchy. Okay? All right. Normally, as it says, a subclass might need to do something different than its superclass. The example he gives in here is stupid, just so you know. He says, assume that everybody who's an employee automatically has a BMI of 19. All right. Again, it's a convoluted example. That's not what's important, but what he's trying to show you here is how you'd override something. Okay. And what do? You just go and you just rewrite it. That's how you override it. That's it. So it says in the employee.m file, override it. This same routine minus sign, float and parens, body mass index, the same exact thing exists in BNR person, all right, .m, except that one says return underscore, or no, I'm sorry, it says, it does the equation, all right? Yeah, it's hard-coded in. But what I'm saying is now we've overridden it. So we're just assuming that everybody who works here, we don't even have to do the calculation. The point is, when you override it, you just put it in again. That's all. But when you put it in, it has to be set up the same way as it was originally. So the return type must be the same, and if it does have parameters, this doesn't. But if it has parameters, they must be put in there too, even if you don't do anything with them. All right. So the method signature must be the same. In other words. All right. Again, notice when overriding a method, a subclass can build on an implementation of its superclass. Now what they do is they assume that everybody who's an employee, their BMI is 90% of what everybody else's BMI is. Does that make sense? So they do the actual calculation to figure out their BMI right there, but before they return it, they multiply that by 0.9. Again, not the greatest of examples, but I think to show you the idea of the call to super, which means call my parent. Since BNR employee is a child of BNR person, this call right here will call the body mass index that's been defined in the BNR person, in the BNR employee.m file. Does that make sense? All right. So they're starting to build a hierarchy. And what they're saying is when you look at this, and this should actually make sense, since everything cascades from NSObject, including things like NSArray, NSDate, NSString, and notice from NSArray you get NSMutable array. From NSDate you get NSMutable date. From NSString you get NSMutable string, etc. All right, so they're just showing BNR person was subclassed from object, and employee was subclassed from person. And it says here, NSObject has a lot of methods, but only one instance variable. So every single time, all right, you create an object, it has this available to it. And it literally is called the ISA pointer, I-S-A. Every object's ISA pointer points at the object that created it. You know, it ISA one of these type of things. All right? So as it says, the thing always knows what its parent is. Okay? And that parent always knows what its parent is. Type of an idea. So, when you send a message to an object, you kick off a search. So again, it will always go and it says, is it defined where I am? No. Then is it defined in my parent? No. Is it defined in their parent? Yes. Then it stops. So as soon as the hunt stops, as it says, when either the method is found or you get all the way up to NSObject and it doesn't find it. In that case, it's going to throw some kind of an error at you. Okay? So it says, let's say that you send a message Fido to an object. All right? To respond to this message, the object uses the ISA pointer to find its class. And it says, did you declare a method called Fido? So it starts to look through here for it. Says if the class has a method Fido, it's executed. Otherwise, it asks the superclass. And it on and on and on until it gets up to NSObject. Right. I don't think there's really that much more to say about it in that particular part of it than that. So, all right, description and this. In calls to NSLog, it says you have been using the token %sign @ to get the object to describe itself. That token, as it says, sends a description message to the object pointed to it by the variable. The method returns a string that's a useful description of the instance of the class. So that's how it knows the type of object that it's working with. Right. And they give examples in here. I don't know if these would help or hurt to go through them. All right. But it's pretty much the same stuff we've already been looking at. So they ask you to go back, and again, I've done this in the examples I've given you, and I've created that challenge. Okay, so that's in there. All right, let's just jump through this one, and then we'll take a break. All right, it says, so far, the instance variables have been mostly simple C types like int and float. But it's far more common to have instance variables be pointers. We've already talked about that. The fact that most things in here are going to be implemented, set up with the asterisk. An object instance variable points to another object and describes the relationship between the two objects. It says typically it falls in one of these three types of things. And if this looks hard, you actually know what most of this is. Object type attribute. So in other words, very similar. I mean, back in the days when we were beginning the intro to .NET class, and you created a button. What's a button? It's a button object, right? It's a member of the button class. And what they're saying here is that's the same kind of thing. It's a value-like object. Okay, for example, an employee's last name would be stored in a string. Then an instance, as it says, a BNR employee would have an instance variable that would be a pointer to an NS string. Okay? We recommend that you always declare these as a property with an implicit instance variable. Okay? You typically will not need to explicitly create accessors. Then you've got a to-one relationship. Notice one is to one and one is to many. Okay? So to-one relationship, a pointer to a single complex object. And they give the classic example. Now, again, no jokes about Utah or anything else, but typically, a person has, if they have a spouse, they have one. Again, we're not talking here about, well, you've been married 7 times. Don't care. What's your current status? Okay? That's a one relationship. On the other hand, how many kids do you have? That could be a too many type of relationship. All right? Yeah, that sounds kind of bad to say it that way, doesn't it? And as it says, when you work with too many relationships, as it says there, they're trickier than attributes or one-to-one. You often end up explicitly creating instance variables, accessors, and methods. So in other words, they're typically more complex, because you may treat it differently for a person who is married but has no kids than a person who's married and has 1 kid, than a person who's married and has 2 kids, than a person who's married and has 3 kids, etc. All right? All right. So now they're coming in here and they're adding to this thing. Notice what they've added. A last name, a spouse, and a number of children. And the idea, when you look at this, okay, that's a simple object. It's a string. This is a complex object. It really is. Because now a spouse, technically, since they're a person, they can do anything the employee, not the employee do, but anything a person can do. All right? And this, we're making an immutable array. Why? Because I will tell you, when I started, well, not here, but when I started as a programmer, I had no kids. All right? Then I got a job and got 1 kid. Then I got another kid. Then I got a different job and I got another kid. All right, maybe that's why I stopped getting other jobs. I don't know. I didn't want any more kids. I don't know. All right. So as it says there, with the exception of the employee ID and the office code, the first 2, everything else in here are pointers. For example, the variable spouse is a pointer to an object that lives on the heap. All right, dynamic. All right, the pointer named spouse is inside the BNR object, but the BNR object that the spouse points to is not. And if you say that just makes my head hurt, then just read it a few times. All right, and it does. It's not. What I believe the author is trying to do here is to just try to show you, kind of under the covers, so to speak, what's happening here. That's all. It says there's 2 important side effects to objects pointing to rather than containing other objects. First, one object can take on several roles. All right? As it says, for example, it's likely that a person's spouse is also listed as the emergency contact for the children, which isn't touched on in here. But when you think about it too, it's not inconceivable that a person's spouse could also be an employee, either at this place or at someplace else. All right? Or self-employed or whatever. Second, you end up with a lot of objects using up memory. That's what this arc comes in. the fact if you're always creating and removing, and it used to be you had to be the person in charge of this. So every time you wanted to create a new object, you had to give it a retain message. And when you were done with the object, you'd have to give it a release message. Now with that auto release pool that you saw inside of main, it's done for you. Now, is there more to it than that? The answer is yes. Because if we're writing a really complex app and we're writing it together, I can go and create an object, but maybe Stefan, maybe he needs to use it, so he gives it a retain message. So even though I give it a release, it still has a counter of 1 because he's given it a retain. Now, in essence, he's taken ownership of it. All right? And that's what they start talking about in here. Okay, I'm not going to sit and read this to you. I'll let you read it yourselves. But that's pretty much what they're getting to in here. All right. And they add some more stuff in here. It's really not that big a thing. So then they add a to-many relationship. Okay? It says, recall that the to-many is a collection object like an array. It says there are 2 important things to know about collections and ownership. Number 1, when an object is added to a collection, the collection establishes a pointer to the object. Second, when the object is removed, the collection gets rid of the pointer to the object. All right? And as it says, the object loses the owner. So they literally have you come in here and start creating assets. All right? I think it'll make more sense when we actually start going in and looking at some of this stuff in a little bit more depth and breadth of coverage. And again, at the end of the chapter, you see it's getting bigger, it's getting bigger. It's a little bit kind of, for lack of better words, it's a little bit confusing because when you do run it, and when I first ran it, I had a very small problem in here. I don't remember what it was, but I looked at it. I couldn't for the life of me figure out why they were getting the output they got. Then I made a couple changes, and sure enough, that's the same output that I got. All right, then they ask you to add some of this stuff to the portfolio. Again, I've done that for you. So it's 4 o'clock. So let's take a break. When we come back, I just want to go over this chapter, which is short, but we'll do that after 4. And then I'm going to go through on the other one. Again, we'll quickly look at some of the material that's in chapter 4 from that other book. All right, so come back in about 10 minutes or so, please.